sine and the cosine trig functions, and then looking a little bit at the composition of trig functions. So here you have an example of the graphs for the inverse sine and the inverse cosine. Okay? So if we first take a look at the inverse sine, notice that we just have one period here, one cycle of that graph. Okay? And it's not going and starting at 0. We'll look here in a little while to see where we're actually starting these inverses and where they're ending. That'll be on the next page here. But just on a notation, there are two ways we can write it. Okay? Down here at the bottom, we have y equals arc sine of x. That's a new one. Okay? But really the arc sine means the same thing as the inverse sine. Or we can do it this way over here on the right, where it's the sine with this -1 right here. That's not really an exponent, that's the inverse. And that's more of what we saw back in Algebra 2 and Geometry when we were doing inverses. Okay? And the same deal over here with the cosine. Notice that the cosine graph, we're looking at one period, one cycle, but it's not starting at 0. We're starting back here in the negative somewhere and coming up here into the positives. And again, we're going to look at what those values are on the next slide here. Okay, but again, notice in the notation, I have arc cosine of x, or I can use cosine -1, which simply means inverse cosine. Okay, so both of these are red. Okay, the arc cosine means the inverse cosine function. Okay, it's just different notation. Over here, I would read it as arc cosine on the left, and on the right, I would read it as the inverse cosine of x, meaning what angle has a cosine of this value. And then here again with the tangent, again, same type of notation. We didn't do much with the tangent graphs, but we will use the inverse tangent functions to help us find different angles, knowing what those tangent values are. And again, I have arc tangent of x, or I have this inverse tangent that we're more used to seeing, and they're kind of interchangeable. We'll be using both. Okay, so we need to be able to recognize both of those different values. All right, so here are those values I was talking about. Okay, if we're talking about the inverse sine or the arc sine function, the domain, which is referring to these x values again, okay, so domain referring back to x, has to be somewhere from -1 to +1. Because if you remember the sine graph, its amplitude only went up to +1 for the maximum and -1 for the minimum. Okay? So as long as this value of x is between -1 and 1, then we're going to get some theta or some y, some angle from -π/2 to π/2. So all of the inverse sines are going to be within that range of -π/2 to π/2. When we go down to the inverse cosine, our x values again have to be from -1 to 1, but notice the output, the range is going to be somewhere an angle from 0 to pi. Okay? And if you think about these things, if you think about the x and y's, okay, the sine has to do with the y values. And in quadrant 1, I'm getting y values that are positive. And down here in quadrant 4, I'm getting y values that are negative. So going from -π/2 to π/2 gets me all of the possible values that are negative and positive. For the x's, okay, I have positive x's in quadrant 1, and I have negative x's in quadrant 2. So going from 0 to pi covers all of the possibilities of getting positive cosine values and negative cosine values. Okay. For the inverse tangent down here, we can take the tangent, the x value can be anything, -∞ to infinity. But again, notice the output is going to give me something between -π/2 and π/2. Because again, I'm looking at x's and y's. My tangent functions are positive in the first quadrant, and they're negative in the fourth quadrant. So that kind of covers the whole gamut. It gives me all of the possibilities for tangent values, whether the tangent values are positive or negative. Okay? So this is a little bit different. We're only going to get out specific values. Okay? So if we look at an example here, number 1, arc sine of -1/2. Okay? What that really means is some angle has the sine of -1/2. Okay? So if we wanted to think about that, we could think that the sine of some angle is -1/2. And we're trying to figure out what that angle is. Okay? So if I'm taking the arc sine, okay, sine of theta is -1/2. Well, when I see sine and 1/2, I'm thinking pi over 6. The sine of pi over 6 is 1/2. And since I'm negative, I know that my arc sine, remember, has to be from -pi over 2 to pi over 2. Okay? So -pi over 6 would be the angle that has a sine of -1/2. Okay? If we look at the second one, the sine, the inverse sine of square root of 3 over 2. That really means that the sine of some angle is square root of 3 over 2. So what angle has a sine of square root of 3 over 2? That's one of our special angles we're supposed to know. And that's pi over 3. How about an inverse sine, number 3 here, an inverse sine of 2, meaning the sine of what angle is 2? Well, that 2 is not part of the domain. That's undefined. There is no value, there is no theta that has a sine equal to 2 because 2 is not part of the domain of the inverse function. Okay? And arc cosine square root of 2 over 2 means the cosine of some angle would be square root of 2 over 2. So what angle would that be? Well, that would be pi over 4. Again, one of our special angles coming from that chart in that unit circle that we're supposed to know. So, a few more examples here. Inverse cosine of -1. The inverse cosine of -1 means what angle has a cosine of -1? Well, that would be pi. Number 6, arctan of -8.45. Well, I don't know what that is, so there we're going to get to the calculator. That's not one of our special values. Okay? So I'm going to check my mode, make sure it's in radians. And to get to the arctan, remember that's the same thing as saying the inverse tangent of -8.45. So in the calculator, you're going to go second tangent and then -8.45. Okay? And on your screen, what you're going to see is you're going to see this. Okay? So second tangent -8.45, and that value actually turns out to be -1.4530. Okay? So the arctan of -8.45, and we should probably clarify to make sure we know that that means radians. When we use the inverse or the arc, we're getting an angle. Okay? So if it's not something that we're supposed to know, like up here in number 5, one of our special angles where I've got a pi, then I'm getting out a radian measure. So same thing with number 7. Second function sine, which is the inverse sine of 0.2447. And that is approximately 0.2472 radians. If I wanted to do that in degrees, then I would just change my mode and then go second function sine 0.2447. Okay. That would be about 14.164 degrees. Okay. So depending on which measure for the angles you wanted that in, you could get either one, but you have to remember that you have to adjust the mode that your calculator is functioning in. So the compositions of these functions. Okay? And this kind of goes back when we talked about functions. F of f inverse of x was x, and f inverse of f of x was x. Okay? As long as we were within the boundaries. Okay? So here the sine of the arc sine of x, as long as x is between -1 and 1, I'm just going to get x back. If I flip it around and take the arc sine of sine y, where y is going to be some angle, okay, some theta, some radian measure, as long as y is between negative pi over 2 and pi over 2, I'm just going to get the same value as y. And the same thing is going to hold true for the rest of the inverses. If I take the cosine of the arc cosine, as long as this value of x in here is between negative 1 and 1, I'm going to get x. If I take the tangent of the arc tangent, it doesn't matter, x could be anything, I'm still going to get x. And the same thing over here. If I take the arc cosine of cosine y, as long as y is between 0 and pi, I'm going to get that same value of y back. Okay? And the arc tangent of the tangent of y, again, as long as it's within this range of negative pi over 2 to pi over 2, I'll get the same value. Now, if these values turn out that they're not where the inverses are defined, if they're not between 0 and pi, or they're not between negative pi over 2 and pi over 2, then we're going to have to find a coterminal angle that is within that range. Okay? And we'll see that in the upcoming examples. So, the tangent of the arc tangent. Okay? If we think about it, this really means, remember this really means here, is that the tangent of some theta is going to be negative 5. Okay? Well, if I figure out what that theta is, and then I take the tangent of that theta again, then common sense would tell me I'm just going to get back to negative 5. The arc sine of the sine of 5 pi over 3. Okay? Well, 5 pi over 3 is not between negative pi over 2 and pi over 2. So what we need to do is, since we'll subtract 2 pi to find something that's coterminal. Okay? So if I take 5/3 and I subtract 2, I'd get negative pi over 3. So I'm actually going to end up with negative pi over 3 due to the fact that the 5/3 pi is not within the defined values for theta, for the y values. Okay? So I have to come down here, subtract 2 pi, find something that's coterminal that is going to be between negative pi over 2 and pi over 2. Remember, this is where those values have to be. So I find one that's coterminal, that's fitting this range, and I would get negative pi over 3. Okay. Cosine of the inverse cosine, well, the inverse cosine of pi is pi within those values. This is saying the cosine of what angle is pi? Well, there is no angle that has that. Okay. I can't have a cosine value of pi because, remember, this number here has to be between negative 1 and 1. So that is undefined. There is no value that's going to fit. So, number 11. Okay, these are a little different because they don't have the same functions. It's not tangent and arctangent. It's tangent and arccosine. Okay? So we're going to approach these a little bit different. And we're going to go back to the idea of a triangle. Okay? So I've got some theta. Remember, arc cosine means the cosine of something is 2/3. Well, if this is my theta, cosine would be adjacent over hypotenuse. The tangent of this theta would be opposite over adjacent. So we're going to use this to figure out, okay, this represents some angle. And the angle down here is now the theta. Okay. So we need to know what this opposite side is. Well, if we use our, I'll just call this x. Pythagorean theorem, so x squared is going to be 9 minus 4, which is 5. So I get square root of 5. So remember, this arc cosine of 2/3 is giving us some value of theta, and we want the tangent of that theta. Well, tangent is opposite over adjacent, so that's going to be square root of 5 over 2, using the right triangle trig. And we can do the same thing here in number 12. the arc sine is negative 3/5. Well, what quadrant would the sine be negative in? It's going to be negative down here. So that's y, or opposite, over hypotenuse, which is going to make this one 4. So the cosine of the angle that has the arc sine of negative 3/5 would be adjacent over hypotenuse, and that's going to be 4/5. Okay. So going back to the idea of using the right triangle, remembering that this really means the sine of theta is negative 3/5, and using that to generate the triangle. And once we've got the triangle, then this arc cosine of gives us some angle theta, and the cosine of that theta would be 4/5. Okay, so see if you can do this one. Give yourself a second, and then pause the video, and then come back to it. Arctan of 4/3 means the tangent of some angle of theta is 4/3, opposite over adjacent, which means the hypotenuse is going to be 5. If the arctan was positive, then it means it has to be in the first quadrant, so this is okay. So the sine is opposite over hypotenuse. So again, 4/5. So take some time, look over those definitions of the inverse functions, the arc sine, the inverse sine, remember the same thing, okay? And then we will do some problems and clarify any questions in class tomorrow. All right, we'll see you then.